Hi there. In this lesson, we are going to be looking at the simple steps in which you can balance chemical equation. The first thing to know is that chemical equation requires that the element on the product side is equal to the element on the reactant side, or the element on the reactant side is equal to the element on the product side. The number of atoms on the product side and the reactant side must be equal. Now, let's look at the practical step in which we can balance chemical equation. Let's take the first one. The first thing to do is to give account of the number of elements you have on both sides. Now, we have hydrogen, the atomic hydrogen. Chlorine gives you HCl. Now, let's give an account of what we have. We have hydrogen to the 2, we have chlorine to the 2, we have hydrogen to the 1, we have chlorine to the 1 on this side. Now, what I'm going to do to balance this equation is that if I should add 2 on the product side, notice that 2 times 1, that will give me 2. 2 times 1, that will give me 2. Notice that I have 2 hydrogen here, 2 hydrogen here, 2 chlorine here, 2 chlorine here. What I have on the right hand side, that's what I have on the left hand side. So let's go to the next one. The next one is hydrogen molecule plus oxygen molecule. So what we have, H2 plus O2 gives me H2O. Now let's give account of what we have. We have H2, we have H, which is 2, we have oxygen, which is 2, we have hydrogen, which is 2, we have oxygen, which is 1. I notice that the oxygen is 1 here and the oxygen is 2 here. So what I'm going to do is that if I should add 2 to the product side, I will have that 2 times 1, that is 2. But 2 times 2 is going to give me 4. Hydrogen molecule will change to 4. That means that I have a work to do on the reactant side. The work I have to do is that what will I multiply by 2 to get 4? If I should add 2, 2 times 2, hydrogen will also become 4. You notice that we have 2 hydrogen, 4 hydrogen here, 2 times 2, 4. And we also have 2 times 2, 4. Hydrogen is 4, 4. And then we have oxygen to be 2. And 2 times 1, that is 2. Now, let's go to the next one. The next one, before we get to the next one, don't change the subscript. Please take note. Don't change the subscript. You're not permitted to change the subscript. What I mean by that is this. We have some cases where students want to balance equation and they have this equation given to them and they say, since we have 2 hydrogen here, let's just put 2 here. No. Don't try that. Don't try that. If you do that, you're going to have a wrong product. Okay? So we don't do that. What we are permitted to change is the whole number, not the subscript, the coefficient, not the subscript. Alright, let's solve the next one. The next question gives us xenon plus fluorine, the atomic molecule. So we have this. Alright, now over here we have that xenon is 1, fluorine is 2, xenon over there is 1, fluorine is 6. Now, what I'm going to do? What we're going to do is that we notice that the xenon is 1, xenon, we don't have a problem with xenon, but we have a problem with fluorine. If I should put 3 to the fluorine at the right hand side, 3 times 2, I'm going to have fluorine to be 6. Now we have 6 here, 6 here. 1 here of xenon, 1 here of xenon. This equation is balanced. Let's go to the next one. Remember, don't change the subscript. You are only permitted to add numbers to the coefficient in front of the element. So we have that sodium plus chlorine gives you sodium chloride. Let's list out what we have. We have that sodium is 1, chlorine is 2, sodium is 1, chlorine is 1. Now, what I'm going to do is that if I add to this side, sodium is 1, sodium is 1, that's good. Chlorine is 2, chlorine is 1. If I should add 2, I will have that 2 times 1, that is 2. But 2 times 1 is also going to give me 2 of sodium. So what am I going to do with sodium on the right hand side? If I put a 2 here, 2 times 1, that is 2. You can see sodium is 2, chlorine is 2, chlorine is 2. Let's get to the other equation. The other equation we have that carbon plus water is going to give me carbon, oxide of carbon, plus at this equation, let's list out what we have. We have carbon is 1, hydrogen is 2, oxygen is 1. Carbon is 1, hydrogen is 2, oxygen is 1. Now, we don't have a problem. The equation is already balanced. Let's go to the next one. We don't need to balance this equation because this equation is already balanced. Now, let's look at it. You can confirm it by yourself. Just take back and see what we have on the account of the element we gave on both sides. Now, we have the next one to the potassium triazo chlorate. It gives you potassium chloride plus oxygen. Now, over here, this is called decomposition reaction. Now, we have that potassium is 1. We have that chlorine is 1. We have that oxygen is 3. Potassium is 1. Chlorine is 1. Oxygen is 2. What am I going to do if I have an equation like this? Okay, now what the problem? I have a problem with oxygen. 3 oxygen here, 2 oxygen here. Now, what if I look at it in this perspective? If I should add 2 to this side, notice that I will have chlorine, potassium to be 2 on this side, and then chlorine to also be 2. 2 times 2, that is 2 times 3, that is 6. My equation will change on this side too. If I should add 2 to this potassium, I have that 2 times 1, is that not 2? 2 times 1, is that not 2? What will I do to these 2 to have 6 molecules of oxygen? If I should innocently put 3 here, 3 times 2, that is 6. You can see that the equation is balanced. So we go to the next one. The next one over there, is potassium hydroxide plus CO2, which gives me this, and then this. Alright, now let's list out the number of atoms we have. We have potassium, 1, hydrogen, 1, carbon, 1, oxygen, 3, potassium, 2, carbon, 1, oxygen, 3, no, 3 plus 1, that is 4, 3 here, 1 here, hydrogen, 2. Now, let's see where the problem is. Carbon is 1, 1, carbon is good, carbon is smiling. Hydrogen is 1, hydrogen is 2, hydrogen has a problem. And then potassium also has a problem. You need to bring down your conjugate, your reasoning to this equation. What do you think I should do? What if this is 2? Let's start with potassium. Let's start with potassium. If I add 2 to this side, it will be 2 times 1 is 2 for potassium. 2 times, this is already 2. Already 1 times 2 is 2. If there's no coefficient in front of the element, we assume it to be 1. So 1 times 2 is also 2. Let's check for the hydrogen. 2 times 1, hydrogen becomes 2. Now already hydrogen is 2 on this side. So hydrogen is good, potassium is good, we are good. Now carbon is 1 here, carbon is 1 here, carbon is good. What of the oxygen? Oxygen we have 2 times 2, 2 times 1, that is 2, plus 2, that is 4. But on this side, for the oxygen molecule, we have 3 plus 1, that is 4. You can see potassium is now 2, 2 potassium, 2 hydrogen, 1 carbon, 4 oxygen, 4 oxygen. Now, this equation is balanced. This is all we got for you in this lesson. We hope to see you in our subsequent lesson where we balance equations that has to deal with polyatomic compound. And in that lesson, we want to start with these, which is the simple basic examples of how to balance chemical equation. We hope to see you in our subsequent video where we balance equation that is much more difficult or harder or higher than this. Also, we have videos on where we balance equation under neutral solution, acid solution, and basic solution. Thank you very much for staying with us till this time. See you in our next